Today we're going to continue our discussion of solving quadratic equations that we began in section 4.3. Remember, a quadratic equation, we have a variable raised to the second power, so we have a second degree equation. We have three main methods that we're going to use to solve quadratic equations. So far we've reviewed our factoring method, which we also discussed back in section 2.6. So to finish this off, we're going to focus on our other two methods. We're going to talk about our square root property and our quadratic formula. So we're going to begin with example 3 at the bottom of page 4 in our notes. And up above this example, we have kind of some details of how we're going to use our square root property to solve our quadratic equations. Right? So if b is a real number and a squared equals b, then a is equal to positive or negative square root of b. What this means is, if we have something that is a perfect square, or even if it's not a perfect square, what we can do is if we have something squared equal to that number, we're going to be able to take the square root of both sides. So for this first example here, x squared is equal to 25. Notice that we have an x squared. So the big thing that we want to look for is, do we have a variable or a variable expression in parentheses squared on the left side? If that is the case, then we're going to go ahead and take the square root of both sides of our equation. So we're going to take the square root of our x squared and the square root of our 25. Right, our square root of x squared, well, what times itself gives us x squared? That's just x. And on the right, what times itself gives us 25? Well, that's just 5. Unlike the stuff that we did when we were solving square root equations in previous sections, we were just focusing on our principal square root. When we take our square root in this section, we want to include both solutions. So we're going to use both a positive or a negative 5. So it is going to be key as you're doing these that you make sure when we take our square root, we don't just get a positive number as we have before, we get a positive or negative. Right, so our solution set for this particular problem is going to be positive 5 or negative 5. Right, if we look at example B on the top of the next page, notice that we don't have something squared equal to another number on the other side. What we have here is a 0 on one side. Right? If we were trying to factor, or if in the next few problems we're trying to use our quadratic formula, having something equal to 0 is good. This is the one case where it is not. So before we do anything, we want to add 3 to move that 3 to the other side. So we get x squared is equal to 3. Now that we have an expression that's squared, we can take the square root of both sides, and then we get our answer. X equals plus or minus, because it could be positive or negative. Square root of 3 is an irrational number, so we're just going to keep our answer as the square root of 3. Our solution set is then positive square root of 3, negative square root of 3. Right? Irrational numbers are real numbers, so they are acceptable answers in this section. All right, C, we're going to start off very similarly to what we did with B. We're going to start by subtracting 4 from each side. Right? Then we get x squared equals negative 4. We're going to take the square root of both sides. In this case, we are limiting ourselves to the real numbers. So in other classes, we may go to the point of breaking these down and looking at these in imaginary units. We're not going to bother with imaginary units here because our universal set is a set of real numbers. If we look at this here, this is not a real number. Right? Our square root of negative 4 is not a real number. So our final answer for this particular problem is going to be the empty set. All right, so far the first three examples that we've done, we've just had x squared equal to some number, and then we've taken the square root. If we look at the next few examples, we have some sort of expression set equal to a number. Right? So we do have our expression squared alone on one side, so we're going to square root both sides of our equation. Our square root of x minus 2 squared is going to be x minus 2. You could leave it in the parentheses if you want to, or we can drop them. Either way is fine. Our square root of 16 is 4, so we're going to have plus or minus 4. Right? That plus or minus, that positive or negative is important. Right, now we want to get x all by itself. So in order to get x all by itself, we want to move that 2 to the other side. So we're going to add 2 to both sides of our equation. So then on the left side we have x. On the right side we have 2 plus or minus 4. Right, since these are all nice integers, we want to go ahead and combine these and write these as kind of 2 nice separate answers for our final solution set. So if x equals 2 plus 4, right, 2 plus 4 gives us 6. And if x equals 2 minus 4, well, 2 minus 4 is negative 2. So our solution set for this problem is 6, comma, negative 2. For e, again, we have a nice expression squared. We're going to take the square root of each side. Our square root of x minus 3 squared is going to give us x minus 3. On the right, well, we can't simplify our square root of 2 at all because it's an irrational number, so we're just going to have plus or minus the square root of 2. We are still going to get x all by itself, so we are going to add 3 to both sides. So x equals 3 plus or minus our square root of 2. We can't combine these at all, but we can write this as a nice solution set showing both of our solutions. So our solutions are going to be 3 plus the square root of 2, oops, and then 3 minus our square root of 2. So 1 plus sign, 1 minus sign in front of our square root. Right, for f, we're also set up nicely to take our square root of both sides. So we take our square root of our left side, we get 3x minus 1. We take our square root of our right side. Square root of 4 is plus or minus 2. So 3x, right, we're going to add 1 to both sides, is going to be 1 plus or minus 2. Right. So we could go up here and start 2 other equations, or we can kind of work through it all at once. I'm going to go ahead and just divide by our coefficient of x. So x is going to be equal to 1 plus or minus 2 over 3. So I've worked it through to get x all by itself. Now that I have x all by itself, as I did up in this example, I'm going to split it into 2 separate pieces to get our answers. So x is going to be equal to 1 plus 2 over 3. 1 plus 2 is 3. 3 over 3 is equal to 1. Or x is going to be equal to 1 minus 2 over 3. 1 minus 2 is going to give us a negative 1 over 3. So our final solution set for this case is going to be 1 comma negative 1/3. So our square root property gives us a nice way of solving equations if we have something, an expression that looks like a perfect square. And we can easily isolate that expression on one side and then take the square root of a number on the other side. All right. More useful than our square root property oftentimes is our quadratic formula. Our quadratic formula we tend to use quite often if we run into something that cannot be factored. So a lot of times what we're going to see when we're given a quadratic equation is something that's in standard form. We have x squared, we have x, and we have a number. It kind of looks like a trinomial, and we want to see if we can factor it to get a result. Well, if we can't factor it to get a result, right, as far as factoring goes, well, we would say our answer is prime. But just because we can't factor something nicely doesn't mean it doesn't have a solution. So our quadratic formula gives us a way to always find solutions even if our problem cannot be factored. Right? When our equation is in standard form, we're going to use this formula to kind of split apart our different pieces of our equation that's in standard form and then work through it to get our solution. So as we are looking at this, remember that our standard form is ax squared plus bx plus c equals 0. So when we're looking at our formula, the a that we see in our formula refers to our coefficient of x squared. The b that we see in our formula refers to our coefficient of x, and the c, right, represents the constant term that is all by itself. So before we can even think about using our quadratic formula, we always want to make sure we are in standard form. Right, before we actually get into solving problems using our quadratic formula, we're going to talk a little bit about this piece that's inside our square root. This piece that's inside our square root, this b squared minus 4ac, is called the discriminant because it can help us tell and determine the number and the types of solutions that we have. So if that b squared minus 4ac is positive, then our equation has two real solutions. And so if we're positive, then we have two real solutions. If we end up with a negative, well, that means really we have a negative inside our square root, right? So if we have a negative, that means we have two non-real or two complex solutions. If our discriminant turns out to be 0, then our equation actually has exactly one real solution. All right, so in example 4, we're asked to use our discriminant to determine the number and type of solution to the following quadratic equations. So again, we're just looking at our b squared minus 4ac for all three of these examples. We're not using our entire formula. We're focusing on our b squared minus 4ac, which is inside our square root in our formula. All right, so we start plugging these in. All right, so looking at this example, our coefficient of x squared is our a. So a is equal to 1. Our coefficient of x is our b, so b is equal to 4. And our constant term, our number that's all by itself, is our c, so our c is equal to 4. All right, so we plug these in. Our b is 4. We're always going to put this in parentheses, especially if we have a negative number. So we're going to have 4 squared minus 4 times 1 times 4. Now if we do the arithmetic, 4 squared is 16. 4 times 1 times 4 is also 16. 16 minus 16 gives us 0. Looking up here, if our discriminant is 0, the equation has one real solution. So our answer for this problem is that this quadratic equation would have one real solution. If we were to try to factor this does factor. It factors into x plus 2 times x plus 2. Both of those give us a solution of x equal to negative 2, which is our one real solution that we would get. All right, so for b, right, our coefficient of x squared is our a, so a is equal to 1. We're missing our x term, so that means our b is equal to 0, and our plain number is our constant, our c is equal to 7. So we're going to plug everything in. b is 0, so 0 squared minus 4 times 1 times 7. 0 squared is 0 minus 28 is going to give us a negative 28. We look back up top here. If our discriminant is negative, the equation has two complex solutions. Right? Complex solutions because we are trying to take the square root of a negative number, which is not a real number, it's a complex number. Right, for C, notice that this one is not in standard form. So before we do anything, I'm going to subtract 2 from each side. Right, so now we really have 3x squared minus 2x minus 2 equals 0. Right, that means that our a is equal to 3, our b is equal to negative 2, and our c is also equal to negative 2. So when we plug these into our discriminant, b squared negative 2 squared minus 4 times a is 3 times c is negative 2. Remember, when we square negative numbers, we get positive numbers. So negative 2 squared gives us positive 4. Right, 4 times 3 is 12, times 2 gives us 24. Two negatives turn positive, so we have plus 24, so we get a positive 28. Going back up here, if our discriminant is positive, we have two real solutions. Right? They might not necessarily be integer solutions, but they are real numbers. So if you're asked to determine the number and type of solution using your discriminant, we're just using our b squared minus 4ac, and we're looking for our sign to make that decision. All right, so now in this last example, we actually are going to use our quadratic equation, our quadratic formula to solve our quadratic equations. So as we're going through all of these, we're starting with our formula here. As we're looking at this formula, again, we always need to start in standard form, so there's a little reminder up here. If we do have fractions, which we're going to see in one of these examples, we're going to make sure we multiply by our LCD to get rid of those. And then once we're in standard form, we're going to plug all of our different pieces in there. One thing to be sure about as you're writing out your answer, that your entire numerator is all one piece, right? So that you want to make sure that that's all one piece, that's all one big fraction over our denominator. Okay. All right, so for A, 2x squared minus 6x equals 1. Well, first thing we're going to do is we're going to subtract 1 from both sides to get this into standard form. So now we have 2x squared minus 6x minus 1 equals 0. So that's going to tell us, as we're using our formula, our a is 2, our b is negative 6, and our c is equal to negative 1. Right, then we're going to use our formula. You do want to make sure you memorize this formula, so if it helps to write it out numerous times, you'll see me do that as we go through. So x is negative b plus or minus our square root of b squared minus 4ac all over 2a. So we're going to start plugging in our different values here. Right, so negative b. So we're going to have a negative 6 plus or minus our square root. B squared is negative 6 minus 4 times 2 times negative 1 all over 2a, so 2 times 2. All right, I'm going to finish simplifying it up here. So the negative 6 is going to turn into a positive 6. Inside our square root, oh, I lost my squared. Negative 6 squared for a negative b squared is going to give us 36. Negative 4 times 2 times negative 1. The two negatives are going to turn positive, so we're going to have a plus sign here. 4 times 2 is 8, so we're going to have an 8 in there. Right, all over 2 times 2 is 4. X is going to be equal to 6 plus or minus our square root of 44 all over 4. Square root of 44 is not a perfect square. So if we finish this off by writing our solution set, we're going to write 6 plus the square root of 44 over 4 and 6 minus the square root of 44 over 4. In other classes, we spend a lot of time trying to reduce these and simplify these. If what you get in your square root is not a perfect square, you don't need to keep going. You can just stop there. All right. For B, we're nicely set up in standard form already. So our A is equal to 1, our B is equal to 10, and our C is equal to 25. Okay. And we're going to plug all this into our quadratic formula. X equals negative b plus or minus our square root of b squared minus 4ac all over 2a. So x equals negative 10 plus or minus our square root of 10 squared minus 4 times 1 times 25 all over 2 times 1. Negative 10 plus or minus our square root of 100, because 10 squared is 100, minus 4 times 1 times 25 is also 100, right, all over 2. Well, 100 minus 100 is 0, so this whole part disappears. X is simply negative 10 over 2, which is negative 5. On the previous page, on the previous example, we saw that if our discriminant, if what we got in our square root turned out to be 0, we only ended up with one solution. Right? We can see that that is definitely the case here for this one. Okay. So we'll keep going. C, we are also in standard form. So A equals 3, B equals 16, C equals 5. We're going to use our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is going to be equal to negative 16 plus or minus our square root of 16 squared minus 4 times 3 times 5 all over 2 times 3. Right, now just to forewarn you with this one, it is going to get a little messy. It's going to get a little cramped in here because of the way this one kind of works out. So as you're working through these, some of these you're going to end up with your answer sooner than others. With this one, as in with a couple of other ones that you're going to run into, you might run into something that kind of takes a few steps to simplify, which is going to be the case for these. So x is going to be equal to negative 16 plus or minus our square root. 16 squared, 16 times 16 is 256. 4 times 3 is 12, times 3 is, times 5 is 60. So inside our square root we have 256 minus 60. 2 times 3 gives us 6. So we have negative 16 plus or minus the square root of 196 over 6. Right. Our square root of 196, it's not necessarily a perfect square that we might be very familiar with, but it is, after all, a perfect square. So this x is going to be negative 16 plus or minus 14 over 6. So if you type the square root of 196 into your calculator, it gives you 14. Up here in this one, if you type square root of 44 in your calculator, it gives you a weird, crazy decimal. It gives you a decimal, you know to stop. If it works out, then we need to take one more step. All right, so then to finish this one off, x equals negative 16 minus 14 over 6. Negative 16 minus 14 is negative 30 over 6, which gives us negative 5. Or x equals negative 16 plus 14 over 6, which is negative 2 over 6, which is negative 1/3. Right, so again, this one gets a little messy. We do get two solutions. We get negative 5 and negative 1/3. I'm going to put my solution set over here since I have room over here. Thinking about this and looking at this, notice that in this one we get two integer and rational answers here. Right? We don't have any square roots left in our answer. What that means is this original problem up here actually could have been factored. Right? So if they are factored, if they are factorable, your quadratic formula actually turns into a lot of work. If they're not factorable, then they work out pretty nicely like in example A. Right? So as you're working through these, be prepared. Some of them are going to be a little easier. Some of them are going to work out nicely. Some of them are going to take a little bit more work to get to your final, most reduced, most simplified, nicest looking solution that you can. Right. I chose D because we see something that has a few fractions in here. So before we start, we're going to multiply by our LCD. So we're going to multiply everything in this problem by 6. Right, so our 6 times our 1/6, our 6's are going to cancel. And we're left with 1x squared. 6 divided by 2 is going to give us a negative 3. So we have a negative 3x. 6 times negative 1 is negative 6. 6 times 0 is 0. This is going to give us a equals 1, b equals negative 3, c equals -6. All right, so we're going to go to our quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals -3 plus or minus our square root of -3 squared minus 4 times 1 times -6 all over 2 times 1. Okay. I'm going to kind of separate off a little bit of area here since this last one turned out to be a rather lengthy problem. So this is going to give us x equals +3 plus or minus our square root of 9, because -3 times -3 is +9. 4 times 1 times 6 is 24. 2 negatives turn positive. 2 times 1 is 2. So x equals 3 plus or minus our square root. 9 plus 24 gives us 33 over 2. 33 can't be simplified, so our solution set for this one is going to be 3 plus the square root of 33 over 2 and 3 minus our square root of 33 over 2. All right, and then last but not least for this section, notice that this one is not in standard form. I'm going to choose to move these both to the other side, so that way we end up with all positives. However, if you choose to subtract your x, that works as well. When we write these out, we want to make sure we get our terms in order. So we're going to have 4x squared plus x plus 4 equals 0. So our a is equal to 4, our b is equal to 1, and our c is equal to 4. Using our quadratic formula, x equals -b plus or minus our square root of b squared minus 4ac all over 2a. X equals -1 plus or minus our square root of 1 squared minus 4 times 4 times 4 all over 2 times 4. X equals -1 plus or minus our square root of 1 minus 4 times 4 times 4 is 64, all divided by 8. So x equals -1 plus or minus our square root of -63 over 8. We are not allowed to have a negative inside our square root in order to be a real number. So to finish this one off, we get the empty set as well. All right, so as you are going through these problems, do remember that it's essential to make sure that you are starting in standard form. As you're working through the problem, make sure that you have your coefficients in the correct spot. Make sure you have the correct signs. Right? And then as you're working through these, again, depending on the problem, some of them do get a little bit messy, take a little bit more work. Some of them work out pretty nicely and pretty quickly based on the problem. Right? So thinking about our quadratic equations, again, we have 3 main different ways of solving them. We can solve by factoring. If we're nicely set up, we can use our square root property, or we can use our quadratic formula. As you're going through the homework for this section, just pay careful attention to the instructions of these specific problems of each different homework problem that you are working on.